in the test, we just had some students seem still have problem with 2's complement binary numbers. It's not that they don't know how to do the operations or do the math, but in fact they've sort of not very clear what this actually means. So let's work on this one. Okay, B. So first of all, how to do it? Just add them as if they are just 2 binary numbers. Okay, let me try to copy this problem here. 1, 1, 1, 0. Let me know if I made a mistake. Okay, here, just add them. Okay, you know how to do this. 1, 0, 1, 1, 0, 1, 1, 0, and 1. Okay, so then, now, this is already in 2's complement. What result we get? So this is, just take 8 bits. Just take 8 bits. So this is 109. Alright, so now, if you want to say, is there an overflow? Now you need to interpret this. First number is actually a -1, interpreted as 2's complement encoded number. It's already done. But if I want to say, okay, interpret it as an unsigned number, this is actually 255. Okay, but we don't do that. Okay, now this one interpreted as a 2's complemented implement number, and this is actually 110. So if this plus this, and actually result is 109. So this matches. So which means this operation is doing a job of add. Okay, that's called add. Okay, doing a job. This is a machine. Okay? And then this result, okay, is 109. That is also 109. So this is perfect. So 8-bit you must keep. So then no overflow. No overflow. Don't confuse, no overflow. Okay? So, and because regardless whether there's a carry or not, in fact this case there's a carry. Okay, but that's the beauty of computer. In fact, the computer, we have the operation called add. It does exactly what you can do too by hand. This is what I did. But then in fact there's no other math operation. So add, there's no such a thing as add, subtract, and multiplication or other. All the math operation a computer can do is just this one. Okay, you would argue, what about multiplication? It is add in some way. And what about division? It's add some way. Subtraction, obviously adding the -1, you see. And later, as numerical computation, integration, derivative, whatever, it's all just this, add. If I ask you a question, what is the single math operation at a CPU level a computer can do? The answer is add. That's it. That's what I just did. And you can do this too. So now, all the question is, how do you interpret the result? Okay, and that boils down to what are the numbers are encoded. Okay, so if you say, well, if it didn't add, you interpret it as a arithmetic. So this makes sense. If it doesn't make sense, you will say there's an overflow. It makes sense. Okay, and so it did. You ask computer, okay, computer, what you did? Well, I did this. I got this 109 for your result. I did -1 plus 110, 109. Okay, no overflow. Overflow the range of accepted 128 to 127. So if your addition is within this range, both result and operands, you know overflow. If any of these are beyond this range, there's overflow. okay, and it has a different relation with this, but there is a way to detect, just use these bits to detect this overflow or not, using logic. And if you want to know that, there will be, I posted a highlight video talking about and you can just use these bits here, the first 4 bits, and this bits, and this, there's a logic directly determining whether it's overflow or not. Okay, so in fact, overflow is a bit in the CPU hardware. If that happens, that wired to these bits. Okay, if that happens, that overflow OV, that's a bit in the hardware CPU. When this overflow happens, that bit will up, then the compiler or the machine will know there is a problem with your computation, or sometimes you can ignore that. Hope this helps. Once again, summarize. You just add them, and then, for example, the last one, again, you add them and just take 8 bits, see if it makes sense. Okay? Okay, don't just, once again, just because there's a carry doesn't not necessarily mean there's overflow. Okay, you overflow here, you see if it makes sense or not, the mathematics. All right, hope this helps.